It's time now for our panel discussion of the day. What are the key data and storage trends in the industry to handle data and storage requirements for AI, cloud, edge, and big data? The future technology map and how SODA should consider to align better to meet the future needs for one data network or data storage demands. Discussing all of this and more are our esteemed panelists, Mr. Jean-Francois Marie from the SNIA EMEA Board of Directors and Chief Solutions Architect at Kilray, Krishna M. Kumar, CNCF Ambassador and Technology Architect Cloud at Accenture, John Bent, Chief Architect at Seagate, and Sasidhar Sopin, DMTS Senior Member from Wipro. The panel will be moderated by Sanil Kumar D, Chief Architect from Huawei Technologies India Private Limited, the member of TOC at SODA and the Architecture Work Group Lead at SODA. Over to you, Sanil.
Thank you, Ashit. And with good morning, all of you. It's very nice to see you all. John, Krishna, Jeff, and Shashi.
Yeah, hi, Sanil.
Yeah. So it's a very, very interesting discussion going on from last 2 days on data connected. What is data connected, and what are the challenges, and what is the future? So we'll just spend some time to discuss about some of the key challenges, future trends, and things like that. Hi all, this panel is a very interesting panel because you will find people from standards organization, hardcore storage developers, cloud experts, AI, ML, edge, whatnot. This is your panel today. And interestingly, if you see, we have 100 years of experience in front of you. Just 4 panelist members, you have more than 100 years experience in technology in front of you. Okay, so let's start with them and try to understand from them what's happening in the industry for this data connected. So we have Jeff, we have Krishna Kumar from Accenture, Jeff representing SNIA and also from Calray, John from Seagate, Shashidhar from Wipro. So I'll start with a brief intro, something interesting about them, and then we will get started. So Jeff, he's I think he has been working in SNIA, I think whole and soul of SNIA, I would say, board of directors, and he's a chief solution architect today at Calray. And something interesting, apart from technology he will talk about, he's a basketball player. More than that, he was a head coach for 25 years. Okay, so if you have any questions on basketball, yeah, we have Jeff here.
Okay, we can go there. Perhaps better than technology.
Yeah, I think people will be more interested in basketball than technology today. Okay, so next we have Krishna, a very good friend of mine, and I would say friend and guide, and I work with him quite some time and interacting in different technology forums. He's an expert, hardcore expert on cloud. So anything on cloud native and Kubernetes, because he is a CNCF ambassador, just shoot to him. He will get an answers on most of that. And currently he's in US, he's working in Accenture. He's part of many industry organizations, CCICI, IEEE, and he's a very, very passionate person to work with technology and the community. He works with a lot of developers, mentor them and support them to grow the technical community in India and abroad. Thanks, Krishna, for joining us. Next, we have John Bent. He's our storage expert today in this panel. He's from Seagate. He's a chief architect in Seagate Government Solutions. He has been working in industry for quite some time. And the interesting point is that he's always working with emerging workloads, emerging technologies, and finding new solutions for storage products. Extreme IO is one of the key areas which is very much interested. Today he will share something very interesting on object storage, I hope. And the interesting part is that he's very passionate on anthropology and spreading social committed activities as a volunteer. John, it's a very interesting thing and novel stuff. Thanks for that, and thanks for joining. And
thank you, Sunil. Happy to be here.
Last but not the least, my friend Shashi from Wipro. He's a distinguished technical member in Wipro. One interesting thing is that I don't know any technology he has not worked. If you see his profile, I think be it cloud, be it AML, OpenStack, or I think legacy OpenStack, container storage. I think every time, I think he travel with technology, I would say. Thanks for joining, Shashi. So we have very interesting panel today, and we will cover some of the interesting topics on edge, cloud, Kubernetes, AIML, some of the use cases, and see that, how trends are moving ahead. So just to start,
thanks,
Krishna.
Thanks for the introduction.
Okay, thanks. Okay, Krishna, I will start with Krishna because cloud is very hot today. I think everything is cloudification is happening. So as each one of you are working in most of the latest technologies today in your area, in your domain. So I would like to know that for our audience, can you share that what are the key challenges which we are facing in data or storage, especially from the future demands, be it AI, cloud, and things like that. So each one of you can share your thought process from your domain. Especially Krishna, you can start with cloud. What's happening with cloud?
Thank you, Sanal. Hi, everyone. Thanks for the kind word. You already introduced me. I work with Accenture in the North America cloud practice. Coming back to the cloud, basically we are talking about data and storage, right? So if you look at what is the right storage to select, right? That's the main problem. Okay. So recently in AWS reInvent, you can see, and he was talking about one of the core problems still is performance or latency, right? That's continued to be the problem. I think that's continued to remain to be the problem. So the vendors are addressing that in different way. For example, AWS was telling they will have local zones like LA and other cities, and they will have high performance storages, and they will have custom controllers and chipset and things like that to address the performance problem. So that problem continued to be there. So people ask in storage, okay, what is the performance? AIML, probably we can talk more. It is more of a, data parallelism, right? People talk about, right? How you parallelize data and access it. But let's come back to the Kubernetes and cloud native world. Cheryl talked about a lot, radar and things like that. It's everywhere. In CCB was talking about Kubernetes, right? It's everywhere. Everybody's.
You must be very happy to see
containers. Yeah, containers and
you,
stuff.
You must be happy to listen Kubernetes everywhere.
Yeah, I think she. I mean, I have listened to her in multiple conferences, and I have met her also. Yeah, so it's Kubernetes everywhere. Everybody knows that. So the point is, how do we connect storage? Actually, it's more of a container or a compute aspect, right? We can talk details. What kind of a storage is needed, and we talk about application resiliency in Kubernetes. Most of the time we talk about compute. We create a Docker image and move the image here and there. But what about the data? So that needs to be addressed, that I have seen. A lot of vendors are trying to get the enterprise level features to the cloud. For example, NetApp is adding their software stack to the marketplace. And Google saying that Microsoft SMB kind of services we can also provide. Like vendors are trying to see what are the features available in the enterprise world and different cloud providers and trying to support each other, actually, that I have seen. Recently, there was a cloud outage from Amazon. You guys might have heard. So now the question is, do we really need a backup and DR for cloud, right? That's the question. Everybody say cloud means everything is there every time. Now, if a region is gone, of course, we know availability zones, right? One zone is gone means you can still get it. What about the region is gone? I mean, you will be 5 to 10 hours on the water, right? So do we really need backup DR for the cloud? That's one interesting question. Okay. Enterprise world, when we talk about hybrid cloud, right? Hybrid cloud is more of data center. It is like edge, 5G, and all kind of devices, right? That's hybrid cloud. So when it comes to hybrid cloud, then how do you manage the data? So that's the question. So all the data set features are available in all kind of hybrid cloud devices. That is not yet clear now. So that is one challenge. But from a service industry perspective, what I have seen is cost optimization challenges. I don't know if people are really addressing that. When we talk about cloud storage, we talk about performance latency. What about the cost? So if it is a compute, let's say compute, you can turn off. If you have VM, you can turn off. Compute is gone, right? Then we can turn on the VM. But what about the storage? You cannot turn off that easily storage. It is there. As soon as you put the data, storage is there. Then what happened to the cost? Then the second factor is egress. Egress traffic is one of the interesting factor in the storage. As soon as you take the data out from one region to another region, or Europe to America or back, of course, GDPR and the issues are there. What about the egress? Egress cost is one important aspect that is to be considered. So cost optimization in the storage, especially from the service industry perspective, a challenge that we have seen. On top of that, there are problems like green energy, because we are talking about too much data has been generated. Then how do we handle that? In security and vulnerabilities are there anyway for a long term, because a couple of days back, there was a man in the middle attack, Kubernetes, it happened. There is a new security vulnerability discovered. You can move from one port to another port, in the multi-tenant world. So what happened to the data in that case? So that security challenges are still there. So we have seen like 3-4 main challenges from a service industry perspective. I'm sure there are more. So I'll stop there.
Yeah, I think security is something like everybody wants, but nobody works during the
design. It is there, always there. It was there. It is there. Continue to be there. And yeah.
So you mentioned, I think before I go to John, you mentioned about the hybrid cloud challenges, especially in the service industry. What is happening in cloud native world? What is the kind of situation in case of Kubernetes for hybrid or multi-cluster or heterogeneous kind of storage?
Everybody is talking about multi-cloud now, like even Amazon, Google, everybody's talking about multi-cloud now. The CNCF also has a bunch of storage options, right? Right now, you look at Rooks, Longhorn, OpenEBS, there are several storage options are there. By using the Rook, you can provision your file store on EBS kind of a volumes and things like that. So in the hybrid cloud, when we say Kubernetes, yeah, you are talking about connecting the disk to the container volume. But we are not, if it's a database, like Cheryl was mentioning, we still prefer to see people use managed services. So it's very comfortable, right? If I'm using MySQL or Postgre, instead of I set up myself, I will go and use the managed services. So Kubernetes, if you come back, we are still talking about data as attaching a disk or volume and manipulating everything in that. It is not a managed DB, or of course you can access it through your applications, but the data is being just handled as a volumes actually currently. So that's what I said when we say data resiliency. When you are moving an application from one cloud to another cloud, we are mainly talking about moving a compute or container part of that. The disk is actually attached, detached, attached, just like the old way. So that is going to change, I think. I think the storage work group is working some of the aspect. Yep.
So I think I see that there are lack of focus, or maybe there are pain points. So SODA has a good chance.
Yeah, I think SODA has some role to play actually. Yeah, definitely. Right. There are some gaps.
Yeah. Okay. So let's go to John to listen from him about. Krishna mentioned about even write storage performance, and we talk about data disaster recovery or data replication. Even the storage support that, and there are this unsettled game between file, block, and object kind of storage types and kind of stuff. So in this current scenario, in the storage space, what exactly happening? I mean, what are the key challenges there between storage types or the storage classes and the performance, or these kind of support for data security, protection kind of stuff? Do we still have serious challenges to meet these latest technology in storage? John?
Yeah, thanks, Sunil. I think we definitely do. And I liked what Krishna was just saying just now, talking about all the promise of multi-cloud and how wonderful it is to, I think SODA and the interoperability and to allow people to just sort of run anywhere is great, right? But Krishna was saying, hey, CPUs and memory, they can go away and it's okay, but data can't go away. And data is very different, right? So a CPU anywhere, you can run on it. You can, your job can show up in India today and in China tomorrow and in Brazil on Wednesday, and it's perfectly happy on any CPU it can find. But the data is always a little bit different, right? Data, sometimes at Seagate, we say that data has gravity. And that can be a real challenge. We have to treat data a little bit differently. And I remember something that my PhD advisor said 20 years ago. He said, storing data is easy. He said, but the problem is, what do you do once you have it stored? And, he was right 20 years ago. And I think he's even more right when you look at the world today. We've done some really interesting studies with IDC, saying, hey, IDC, because we're Seagate, right? We want lots and lots of data. IDC, how much data is the world producing every single year? And if you look at the graph, it's amazing. It's obviously exponential. I don't think that comes as a surprise to anyone. In the year 2025, IDC is predicting there's going to be 175 zettabytes, right? Not gigabytes, terabytes, not exabytes, not petabytes, zettabytes of data. It's unfathomable. That's the data being created. But of that data being created, IDC thinks that only about 10% is going to be saved. So 175 zettabytes, only about 17 zettabytes is going to be stored. So it's 10%. And what you see is that the amount of data being created is exponential. The amount of data being stored is also growing, but it's growing at a slower rate. So the percentage of the data created that's being stored is diminishing year over year. And that's very counterintuitive, because we know that the more data you have, the better your science. If you're doing data analytics, if you're doing, machine learning, any sort of, big data exploration is better with more science. The scientists have studied this, right? If your training set is larger, your inference engines are more accurate. Your insights are more immediately actionable and more precise. So why, right? What is happening that the percentage of data being stored is diminishing when we know that data is so valuable? And it's just that we have too much data, right? And that's a weird thing for somebody at a storage company to say. We'd like to help the world store all that data, but it's too hard to store it. It's too hard to manage it. The data has gravity. It's too hard to find the interesting parts, the subsets of the data that are interesting. We have data silos, right? So it's too hard to figure out which of your data silos is your data set in. Then once you find your data set, it's too hard to find interesting pieces in your data set. And it's also too hard to find correlations across data sets stored in different silos. So I think these are a lot of the challenges that are happening, and quite frankly, it's too expensive as well. And, Krishna said that as well. You have to think about your egress costs. There's a famous song by an American rock band, the Eagles, Hotel California. Yes. I forget the exact lyrics, but it's like, you can check in anytime you want, but you can never leave. And sometimes people say that about cloud storage. Yeah, you can put as much as you want in, but as soon as you want it, and that's challenging because data has gravity.
Very true.
So I think there's solutions to all of these. I'm going to leave it with the challenges, and we'll come back around.
Yeah. So I think you closed with a very nice one, that you can get and you cannot get out. That same with storage vendors and cloud vendors as well. So that is when the standards or certain unification is required. So that is when we have an expert on that, Jeff. So Jeff, apart from standardization, of course, I think you can talk hours on standards. I know. Especially on the latest technologies like edge. And also you can also touch upon some of the challenges. I think John mentioned that the data, one important point is that not only this vendor lock-in is important, once you have a data in one place, it's not very easy to move because of legal and other compliance factors. So even the compute can move, memory can move, but the data cannot move. It is not because of any other vendor lock-in and things like that. Because a data in one region cannot move into another region just like that, because there are legal compliance. So there are things on technology, there are things on standards, there are things on legal. Can you please help us to understand a bit more?
Yes, thank you for having me here. Thank you, John. I love data is gravity. That's why I changed my background, right? I see all you guys having those stars.
Yes.
And I say, this is
put the
right.
same one. Thank you.
Yeah, both of you like gravity.
Yes, it's all about gravity. And when you have that in mind, you understand all the challenges that have been shared already, right? Moving data around is a challenge. The more data you have, the more weight you have, etc. So yes, so perhaps I've played as much basketball as I've been playing in this industry with regard with my gray hair. And it's interesting to see things moving around. I agree with the presentation before with standards. It's important because there are so many variety of data that it's impossible one single company has a proprietary code to manage tool, right? And the community may help solve. So I believe community and standards may help solve all the things we have to analyze, etc. Again, agree with many data John shares. From an edge perspective, that's interesting. It's not just about the gravity, obviously, but it's about the quantity of things generating data, right? From the many years I have been working in this industry, and my colleague here would perhaps share the same. Everything was well organized in the data centers. Everything for the business was stored in databases, well organized in tables, very easy to query. It's done, right? We see the race for NoSQL database with object store to have those data lakes, etc. And as John said, many companies store as much as they can, promise what to do with that. Again, I agree profoundly on that problem, right? For the past years, I've met hundreds of customers saying, where do I start? So the channel, and coming to the edge is exactly the same, right? You have all those devices, but what's an edge, right? It could be a factory, it could be a smart city, it could be a small edge, it could be a robot, it could be a drone, it could be whatever. The first challenge I see is in IT, we're used to manage thousands of devices, tens of thousands of devices. If it's network, perhaps hundreds of thousands of devices. With edge and IoT and all those technologies coming all together, it's billions of devices to be managed. It's another magnitude in terms of management, and also in terms of data and generated. And it's impossible to say that tomorrow, all that data will go in the data center or in the cloud or in only one place. And the definition in edge, if you take the AI paradigm, edge is defined as the first location which is heated by data in which you have compute power. To do what? To do analysis, to do filtering, right? I've been lucky enough to visit CERN in Geneva, close to Geneva, right? Those guys, they're all analysis, they're all trying to find the origin of humanity, of the universe. And what they are doing particle collisions. Those collisions are generating other particles, right? So they have a big engine. Imagine 100 meters under the surface, an engine which has a 5-floor building engine, right? Massive engine to analyze those collisions. In order to do the filtering, and it's exactly the same we have at the edge, in order to do that filtering, they need to drop nearly 90% of the data they collect because they don't have the power to do it, right? So they filter based on knowledge. Oh, I know with this event or this trace, this magnitude trace, yeah, I can remove it. But many of them, they don't know about it, right? But they don't have the power to analyze. And this is exactly what's happening. This is one, so the amount of data generated, the power needed to filter, and the density to do this filtering, because at the edge, you may not have the cooling and the right power, the energy to do all the filtering you need, right? Another thing to be mentioned here, and I think this is perhaps driving a lot of discussions, because IT is dispersed. It's no more one location, right? Sachinda mentioned cloud, right? So I've been grown in, this new trend from edge to cloud, from edge to core to cloud, from edge to data centers to cloud, right? So data is in movement. So we understood gravity is a challenge, but another one is security. Maybe you have seen in the past days, one of the most powerful security agency or companies which have been attacked by ransomware. This is a challenge, right? So you don't want to expose your company data to that type of things. So one of the key challenge for all the things we are discussing is now security. So I'm working on 5G projects. It's interesting if you compare 4G to 5G. Or for 4G, all the intelligence is in one location, if I can say so. 5G, it may be dispersed to 4 to 5 to more locations. So you're going to have multiple filters plus transport. So you need security in the middle. So quantity of things, generating data, first challenge. Second one is quantity of data being generated, and to compute, you need to filter, and security are the 4 things I see as big topics.
Yeah, thanks, Jeff. Yeah, before going to Shashi, one small question out of interest. You said 5G, when it comes to 5G, probably the data mobility part of it, especially the bandwidth, the kind of bandwidth that is going to provide. Do you think that it can disrupt the current edge topology or edge architecture?
Oh, yes, because it is completely changing the game. When you see the projects and the demanding in terms of power at the edge, the challenge that we have seen, the change we have seen in IT, say, hey, okay, we can use generic computers, right, and have software defined on the top of that. It's good enough. This is not going to work at the edge. You need acceleration. You need acceleration card. You need acceleration engines to treat them, because you can't manage that all, right? Billion of things, 10 of billion of things, right? That's going to be a challenge. And if you compare 4G to 5G, 4G was for human, nearly, right? All phones. 5G is for everything. So everything is going to get connected. So the challenge is also, yes, around the fact of what technology will help you accelerate. And we see more and more the need for acceleration, hardware acceleration back, right, in the game.
So more importantly, do you think that the edge storage or the storage at the edge devices, that kind of thinking will probably go off if 5G is there? I mean, 5G.
No. The storage will be very important, right? Because as John mentioned, you need to collect the data. You can't store in the core. You can't store in the cloud, right? You need to store at this edge and analyze and send, because you need to filter and send less to the location where you're going to do the extra filtering, or bigger analysis, or as John said, it's important to have massive data lakes in order to make decisions. But even though the biggest one, you cannot do analysis, you need to filter down, right? So yes, there's a big data challenge at the edge.
So there is a big thing, that is the distributed heterogeneous storage still will be important at the edge.
Yes, and as was mentioned before, imagine all the edge around the world collecting data from different culture, different countries, different whatever application. And imagine if your data center is in another country, how do you manage regulation?
Yeah.
That's going to be very interesting.
True. Okay. Yeah. Thanks, Jeff. So, Shashi, I think you are going to get a mix of all these inputs because you are master of all these technologies. So, see, we have certain points. John mentioned that we store less. Huge data is generated, but we store the storage data. The stored data is diminishing. 1 point. Second, Krishna also mentioned about the cost optimization part of it, and also hybrid. And Jeff was mentioning about the data security, the volume of data that is generated at the edge or the IoT space. So a person who worked on different solutions on AI, ML, and caters to different customers. Where do we stand there? Because on this demands on data protection or data security, on the cost, I think cost obviously important. So what is the current challenges you face in your solution building, especially on these technologies?
Thanks, Sunil, for earlier introduction, and thanks all the panelists for your initial inputs. So let me begin with a quote. So earlier we used to call data as the new oil, data as the new electricity. Now I can say data is the new oxygen. So without data, we cannot survive. It has become so important nowadays. And as Jeff and John mentioned earlier, a lot of data is being translated, whether it is by storage companies, around 175 petabytes of data, or sensors emitting data, or platforms emitting data. So all this data is sitting, but data can be classified as data can be at rest, and data can be in motion, and same data can be in doubt. So whatever the data is in doubt, so for example, moving that data from one geographical location to other region, what are the challenges, whether it has to go through GDPR standard, or nowadays if you see many cloud vendors, be it Amazons of the world or Google or Microsoft, so they're coming up with region-based data centers. Right. Also, we have a heterogeneous hybrid and multi-cloud environment where you can process on-premise some of your confidential data or private data, push that data which you feel confident it can be in public cloud, you can push it to public cloud, get it processed and bring it back to your on-premise. So this can be the trend going forward. But the challenge here is especially the sensor data. So we call it as a time series kind of data, because a lot of times what happens is you have to process the data, as Jeff mentioned, at the edge. So at the edge devices, you may not have the required compute level or storage capacity. So earlier we used to talk about in megabytes. Now it is in gigabytes. Going forward, it will be in terabytes. So it will be very difficult to process that kind of data, especially at the edge. So once data is collected, stored, and analyzed, how we can prevent and enhance the events. So not all data that is required is relevant, right? So how to get rid of unwanted data? So that will be the challenge, especially in storage. We are a lot of new trends like fast storage, low latency, more capacity are becoming trends nowadays. But how you address these kind of things using existing storage? You cannot just migrate data from one place to other place very easily, right? So you need a lot of bandwidth, network bandwidth. For example, say Google has come up with their own fiber optics connectivity, where they'll guarantee certain terabytes of transfer rate. So that may be the trend I see going forward. Along with that, how to build a cost-effective data management platform which addresses all these challenges will be a next trend, because you have to have multi-cloud, hybrid cloud, edge devices, sensor data, platform data, storage devices coming up with a lot of advanced storages, technologies like NVMe, SSD. So with all these trends, one has to think, what is my architecture which will address all these challenges? How I can build a robust and heterogeneous kind of architecture where it will fit in all AML based algorithms, or be it new technologies of storage, or how to address cloud migration or cloud handling cloud kind of data, be it containerized or Kubernetes kind of failure kind of a scenario, as simple as that, or it can be as complex as multi-cloud, hybrid cloud kind of data.
Yeah, thanks, Shashi. Actually, I like that the term used, that data is oxygen. Yeah, so that's good for all of us, because who are working on storage and data. Okay, so I just before going to the next question, I just wanted to check with you one more point related to this. That see, when you have the storages, especially on IoT side, I think you have worked with IoT solutions. There are various kind of devices, and there is possible storages happening on probably towards the edge or in the immediate data centers. So do you see something like there are a lot of different types of storages? Like it can be SD card, it can be tapes, it can be for archival. Still, people are using that, and it can be SSD, it can be different kind of storages. Do you see what are the key challenges you face in terms of managing the storage itself? Say, for example, you have huge number of storages, and what kind of monitoring you do on the storage, whether the storage performance is okay or not, and what are the indicators which can help you to even retain the good performance of your application workloads. So do you see this as a key challenge, or do you have some solutions there?
Yeah, definitely. This is a key challenge, especially because, as you said, right, there are multiple devices, and all these sensors you have to connect either to the gateway, and from gateway you can expose it to the cloud, or you can store and process the data in cloud. But as you rightly said, the moment you shift to cloud, the latency will be introduced, because the amount of time, whether even though it is in nearby data center, it has to traverse through so many hubs using different routers, gateways, and all. So the amount of data, the more closer you store to the IoT devices and gateway, the better it will be. For example, if you take example of smart cities or smart homes, right? So a lot of sensors emit data. So even at the gateway, how fast you can process this using latest technologies, or at the edge device, how fast you can process it. So instead of having multiple different types of devices, so that introduces a lot of challenges. As you said, integrating that and analyzing these kind of data more rapidly, and these kind of continuous data which keeps on coming, as I said, time series kind of data, how faster you can process it, what solutions you can build on top of your gateways and edge devices, right? So especially that will be the key challenge. So one solution can be like to build a cost effective solution, kind of a SSD or NVMe kind of a storage, which will address latency and compact storage with the higher capacity and all. So that may be the trend. Even I heard that a lot of new inventions are being made in storing data. They have developed a DNA RNA kind of storage where entire global data, entire world's data can be stored on 1 square inch or 2 square inch of a disk, or even glasses, right? So one glass, a cylindrical glass, they're planning to store data in 5D, not even 3D, 5-dimensional ways. So traditionally we used to have traditional disk where we used to read zeros and ones in a horizontal way or vertical way using traditional read write disk head, right? So that trend is now shifting to NAND technology using your SSD and NVMe kind of flash devices. So even going forward, I think like quantum computing, where compute process has been increased n-fold. So even in storage, I believe smaller devices will be invented, which can sit at the edge, which will solve most of these problems.
Yeah, thanks, Shashi.
Sanil, I believe we do have some questions from the public.
Okay, so can we take after a few minutes? I'll just go one round.
Sure. This is a time check. We are around the 20-minute mark right now. 20
Okay.
minutes.
Oh, we have 20 more minutes. That's good.
Yes.
Okay. So, yeah. John is there. I think John's video is off.
I'm sorry. I'm here, Sunil.
Yeah. It's okay. Yeah. So, John, see, we have seen good news for you is that the storage is inevitable and data is oxygen. Okay. So
I know, that's great.
So basically, in storage, I know that you are. I mean, one of the areas where you work on is on object storage areas, some research and kind of stuff. So I'm just shifting a little bit that. Okay, so we need storage, and there are various types of data coming in, the huge volume and stuff like that. So in this storage space, to meet these challenges, especially going forward, the list of challenges what all of you mentioned, to meet those kind of challenges at the storage side, what are the key solutions, new solutions coming up? And maybe you can touch upon object itself.
Yeah, of course. Thanks, Sunil. I also want to come back to something that Shashi just said, which I'm not sure about. You know, he said that one of the challenges, there's so much data, and one of the challenges is figuring out what you don't need to store. And on the one hand, he's 100% correct. You know, customers come to us every day and they say, I've got this problem. I've got all this data. You know, I've got data set 1 and data set 2. I can't keep them both. How do I choose, you know, which to delete? So absolutely, some way of, you know, determining the relative value of different data sets is important. But I don't think that I would go so far as to say that some data is worthless. You know, as a simple thought experiment, if you could store data for free, would you ever delete anything? And I think the answer is no. You would keep just about everything because you just don't know. You know what's
even multiple copies,
right? Yeah, you would store it. If it was free, not only would you store it, you would store it with 7 copies everywhere, right? You know, like everybody's doorbell now has a camera in it, right? And they take videos every single time, you know, a neighborhood cat walks by the door. And you might think, I don't need to store all those cat videos. But for one thing, people like cat videos. And the other is you never know, right? Which of those videos might be important because one of your neighbors lost their cat, right? So I think it's very hard to know something that looks like it doesn't have value today. A week from now, a year from now, it might have value. And so then I think that starts getting to your question, right? Which is, okay, well, how do you know a year from now that it has value? If you started accumulating, you know, 175 zettabytes of storage, you can't just say, oh, okay, well, now go through all 175 zettabytes and look for canned cats, you know, coming from my neighbor's house. It's going to take too long to look through 175 zettabytes of data. And so I think that, you know, certainly in regards to object storage, right? Object storage has evolved to address this very specific case, right? I mean, when we first had object storage, right? People said, okay, give me a big blob of data and I'm going to give you an object identifier. And then I'll build a very, very scalable system for you. And people said, oh, okay, well, yeah, that's good. But you know what? I'd like to give names to my objects. And we said, okay, fine. You can have named objects in your object store, right? And then people started saying, you know what else I'd like to do? I'd like to put labels onto my objects, right? So, you know, in the S3 protocol, there's user metadata. And every single object has the ability to have arbitrary key values associated with it. And so I think that this is really sort of the future of object storage. And, you know, file systems had that too, right? file systems had extended attributes. And, it's very similar, but I think one of the differences is that I think that object stores, one of the keynotes right before our panel, I forget the woman's name, right? But she was looking across sort of this survey of all of the really fantastic databases that are out there, the ones that are, SQL, the ones that are no SQL, a lot of them are just key value, engines. And so a lot of the object stores are building either external or integrated key value stores to put all of those labels in and then index them and automatically create all sorts of histograms and sort of the lambda function, so that when your object goes in, you can register events on the basis of the labels. Some of those events can do some of the post-processing to add more labels. And so I think that this is sort of how, AI and machine learning, which very much rely on labels, are converging with sort of this evolution of object storage. And so, yeah, data is oxygen, and we breathe it in and we give out carbon dioxide. And you might think, oh, the carbon dioxide is worthless, but it turns out that the carbon dioxide has a role too. So, we need to label it and we need to keep all of it.
I can understand. Everything has to be stored. Otherwise, storage is not required, right? Ben, John?
Hey, it would be much easier. If all we had was compute and memory, it'd be much easier to build distributed architectures. But yeah, you can't do anything without the data.
Yeah, hey, thanks. So let's go to Krishna to just understand. See, today, we have seen different challenges even in the cloud, edge, and even on-premise. But specifically, like many of the edge platforms they started calling it as edge cloud, right? Cloud is coming to edge. If you see most of the cloud vendors, I think they are started providing edge solutions. Now, in this kind of a scenario, do you see some new with respect to cloud storages? Or what are the key things happening in cloud storages or in cloud technologies to meet this challenge? Coming to edge and meet this.
Yeah, we are approaching the 10-minute mark because we have some questions as well. So I would.
Yeah, sure, Anvit. I will just quickly pass through. So maybe what we can do is that I think Krishna, Jeff, and Shashi, can you please cite some few key technology trends we should watch out going forward? Krishna, to start with.
We are running out of time.
Yeah. So this is a prediction time, okay, Krishna? Krishna can always predict.
You want me to start with?
Yes, please.
Okay. I believe, I think the selection of a storage, exactly what to select and things, should be left to some intelligent compute engine or compute applications, so that it will store your data where it is best to store. Okay, we are not there. Probably that is the one of the cool thing we could have actually. Then we don't have to talk about whether it's a block or file or this or whatever. Now that this particular application need this set of data, that application should be intelligent enough to figure it out, where to store data, how to retrieve data, how to process the data. So
basically you give the data and ask the data, that's all.
Yeah. Give the data and ask the data and it will get it actually. So the SODA can make it work, that would be one of the things. Great.
I think we are listening.
Second thing is again from a service industry perspective, there is an SLA based most of the things, right? So if you say something has to put it in and we have to agree on some SLA, whether storing or protection or retrieval or whatever, right? It has to adhere to some standards or some principles actually. That is also mostly manually done at this point, because there are so many enterprise data features available, storage features available, and cost I already mentioned. There is no real one-to-one mapping, like this can be done for that. It's all manually done right now by the industry. So that can be kind of automated, or at least come into some kind of a tabular format of comparison format of, then that makes more sense.
So basically you are seeing some smart solutions to come.
Yeah, smart solutions are not there. Actually, it is being manually handled by using some templates and Excel sheets and things like that. That I have seen. Of course, then we talk about hyper-converged infra and commodity hardware. Again, it comes to what is best, actually. I mean, you can choose this or that. Then how do you choose? I mean, which one is there, actually? It's a huge difference between choosing that. So some of those aspects can be considered from a broader cloud perspective, actually. And edge, of course, I told you some intelligent way the data can be stored, then that let it figure it out rather than we choose block or file or whatever for the edge.
Okay.
I'll stop it there right now.
Thanks. Thanks, Krishna.
Yeah.
Going to Jeff. Jeff, do you have anything very interesting, 2-3 technologies to be watched out to meet these challenges going forward?
Yes, the question is interesting because I need to filter down. So
You're going to
be
predict
an edge device. What I'm seeing in terms of the data management are two big things. It's related to the quantity and the speed of analysis we need to put together. I see NVMe and all those related NVMe technologies really linked to Flash to change the game. Watch at my presentations around NVMe, right? NVMe is moving parallelism to data management or data analysis, right? Replacing SCSI little by little. It's going to take a time, but so it's going to push things. It's going to push boundaries, and it's all about massive parallelism. We speak about that, right? AI is all those new algorithms, all those new software needs massive parallelism to take benefit of all the resources, right? But you need to access data in a parallel manner. So we have the protocols, NVMe, NVMe-OF, all those things. What is pushing is all the software stack. So everything has to be reinvented. No one knows very well how to program in a parallel manner. Containers will help, right? Because they are parallelized by default. They are pushing boundaries on how you develop your applications, and it gives a good direction. In my company, we do massive parallelism at the processor level, and it drives all the things. And it's interesting to see how much difficult it is to embrace that new trend, because if this is not a natural way of doing things. Many human, we do one thing at a time. Now we need to think many things at a time. So I see that as a big challenge.
Okay. So NVMe and parallelism, the real parallelism.
Yeah, NVMe, yes, and all the related things to do parallelisms and containers. I see many projects at the edge. They are all container-based, and there's a good reason why, because it's lightweight. You can move them around, right?
Yeah.
And that's one aspect. It's embed security, and the other aspect is as soon as you have your platform is parallelized.
Right. Yeah, containers are just like basketballs. Anywhere you can throw, you can put it.
I would have loved to have the agility of the containers.
Okay, going to Shashi. Shashi, quickly, can you tell some 1 or 2 key things going forward we need to watch out?
Yep. So let me begin with data, as John rightly said. So even though some of the data is irrelevant, but how intelligently you manage using AML will be the going forward one of the key aspect. So other challenges is how faster you can process the data, be it parallel IO processing or parallel CPU processing, especially GPU augmentation will be the next biggest trend. And apart from that, I see AI, especially in artificial intelligence, how ethically you develop new algorithms, how you handle ethical algorithms where, for example, facial recognition can be used in various manners. It can be used for good reasons as well as bad reasons, but how you can control it will be the next biggest trend. So one, especially auto ML. So completely automating the machine learning algorithms from training the data till inferencing or predicting will be the next biggest trend, I believe, because AutoML is picking up. So many companies, be it OpenAI, GPT kind of standard, they're investing on it. So going forward, AutoML will pick up.
Okay. Yeah. Thanks. Thanks, Shashi. I think Anvit, how much time we have?
We are almost out of time, so
maybe I'll just pick 1 or 2 questions.
Yeah. So actually, you did pick one of the questions. The first important question was, what single trend do you see in the data storage side that will change AI
Yeah,
applications?
that is already done, right?
Exactly. So I believe that was answered. There is another one which says, okay, let me see. There are a few I've noted here.
Maybe I can just read out. I have this.
Okay, you can just do that.
Okay, maybe I'll just take one or two questions and then go for the closing remarks. Okay, so what are the key practical hindrances we face or foresee when we deal with the data management API standardization? Let me shoot this to Jeff. I think Jeff is waiting for that question. What are the key challenges? What are the key challenges or hindrances we see when it comes to the data management API standardization?
Yes, it's interesting. There are some good initiatives around, if I consider SNIA, Redfish and Swordfish. Those are let's say, standards to help manage devices. The other trend associated with that, which is a challenge, is composability, right? Many guys, we all mentioned that it's very difficult to find the best components, right? So one way is to have a huge amount of them and select based on your workload, etc. So you need a standard, and Swordfish may be something good for that as well. But for the many years I've been working in this industry, all the vendors, any vendor, have had his own interface without respecting the standards, which make the things very difficult. And I think, again, in terms of the sharing and the community and the challenge, all the challenges, I think it's important those standards are emerging. So the one I know I'm working on those days are really Redfish, Swordfish, that are trying to give a direction in terms of management, device management, not data management, which is a bit more different, right? Yeah. Data management. And I think it's all about the formats, right? How do you transfer the data? But I don't think it's data management per se, right? Because there are so many applications and sort of data that I think it's, in order to transfer, is what data format, and do you have the tools to manage that format? I would think about the format itself, but not an API to manage it all, because I think it's so much in terms of variety that I don't think it's possible to define a standard for management.
Yeah, thanks, Jeff. That's good. So maybe I'll take a last question before we do the closing remarks. Maybe this can be answered by Krishna. Are on-premise cloud deployment taking off like AWS Outpost? Krishna?
What's the question?
The question is, are on-premise cloud deployment taking off like AWS Outpost?
Yeah, I think even the recent announcement in the AWS reInvent, Amazon was pushing for AWS Outpost, including the Kubernetes world. You know, they have something called EKS and ECS. That's a container. They're going to make that open source, and they're going to put it. People can take it and use it in the hybrid their own premises. So the thing is that now all the major cloud vendors, including Google, they have Anthos. Everybody's coming out and saying that, hey guys, whatever we are doing in our cloud, the same API, same set of the software stack and features, you can take to your on-prem and you can implement. So there is no difference in the user experience, right? And you can just connect your hybrid with your public cloud and everything works seamlessly. So yes, that is going on, and there's a big push from all the major vendors. In fact, I basically works now in one of the big cloud project with Google. We are on Anthos. I cannot tell more than that. It's basically a hybrid multi-cloud actually. You get the exact same experience you have in a public cloud in your private cloud actually. And Amazon, I see that in their recent reInvent, the Amazon CEO was pushing for that actually too. So I think it will be there. It will be there. Yeah.
Yeah. Thanks, Krishna. I think Prakash, you should get in touch with Krishna because he's the right person.
Yeah, Prakash is in our team. I think Prakash is CCI, CI, and he's OpenStack. Yeah, we work together. Yeah.
Okay. Then you can connect with him. Okay, yeah, it was very nice. I think very interesting discussion and sharing your valuable expertise for the audience of SODA. And just to get it closed, I think I'll just start with John. John, again, few words about the panel discussion today.
Yeah, I just want to close on a positive note. You know, we talked about all the challenges, but I think that there's a bunch of new trends, you know, and you asked Jean-François how, you know, what are the new emerging things? And he said there's too many to talk about, you know, but I think if I was going to pick just a few, I would say, you know, there's a convergence of new hardware technologies that are really going to combine, and the sum is going to be greater. You know, the whole will be greater than the sum of the parts. Non-volatile memory over fabric, NVMe OF, GPUs, some of the things with the disk drives, multi-actuators, and HAMR. And what this is going to do is it's going to give very low latency, very high bandwidth access to massive amounts of data with an unbelievable connectivity to these fantastic learning engines. And when you combine that with, you know, object storage like Cortex and the other object stores out there that are bringing all of those technologies together, and when you bring it together with machine learning and the labels that we have on the data, then I think, you know, for a long time, artificial intelligence was promised and it was overhyped and it was disappointing. And finally, it's achieving fantastic things. And we're going to be able to solve more data. We're going to be able to save more data. We're going to be able to search more data. And we're going to be able to solve the world's biggest problems. I saw a question in the Q&A about, is this going to help, you know, poor? Is AI going to help poor countries? Yeah, yes. Absolutely. You know, we're going to develop vaccines more quickly. We're going to figure out how to distribute them around the world. We're going to have better climate modeling, and we're going to, you know, stop the ocean level rise. I am pretty optimistic about what we can do when we save more data and we combine all of these new hardware innovations.
Yeah, that's really positive, and we continue to get the paycheck because we work in the technology. Okay, Shashi, can you just one or two, I mean, few words, because we are out of time, about this panel discussion, just closing remarks.
So thanks a lot for giving this opportunity. It was very positive discussion. All the panel members gave a lot of very good inputs. So let me say, along with AutoML, I believe one another thing is Internet of Behavior, IOB. So this is again one of the things which is picking up. If you see whatever what it means to be a human being in the digital world, because of huge data available to us. So how intelligently we manage. Earlier, if you see, so all the mobile phones with camera, they used to advertise AI-enabled camera, right? So nowadays, if you see, it has become a default feature for any mobile if you buy within the range of certain price, right? So going forward, AI will be implemented, John and everybody said, be it in healthcare, be it in domains of automotive industry, or manufacturing like robotics and drones. So everywhere you'll find AI implemented by default, and especially COVID kind of situation, right? People have come up with a lot of challenges were able to be solved because of AI, be it finding out a vaccine at the speed of what we found in this decade compared to last 50 years. It is becoming very, very quite advantageous. So having said that, so data still will become oxygen, water, carbon dioxide we emit out. We have to filter out carbon dioxide and take out oxygen out of it again.
Thanks, thanks, Shashi. I think, yeah, Jeff, few words, closing remarks, Jeff.
Yes, I love the positive notes. It's in terms of humanity, what I've seen is when you have to face challenge to be creative. And I see that creativity those days. The many challenges, the more challenges, the best the creativity. So I'm completely optimistic, even the challenges, right, that we will be able all together. But it's not a one person or one company thing. And the new thing is, as I see here, it's about community, it's about sharing, it's about all together. And I firmly believe that's going to be the future. Is all the human being with all the knowledge and the sharing of the things we do that's going to solve the problem we're going to face. We are facing already with the crisis, the COVID, and all those things. It's all together. And you see that, right? It's not one that is solving. It's impossible anymore. So it's, again, massive parallelism, but in terms of human. And I firmly believe that we can do it.
Thanks, Jeff. Krishna, just a few words on closing.
Well, covered very well. We talked about a lot of technologies. So everybody talked about a lot of data, a lot of storage vendors, a lot of APIs. I hope SODA will be the real mediator there to play that role of integrating all together and make everything seamlessly easy to use and easy to adapt.
Those are golden words, Krishna.
All the best, SODA.
Definitely.
Yeah,
So collaboration will be the next big thing.
Yeah. So thanks, Shashi. Thanks, John. Thanks, Jeff. Thanks, Krishna. I mean, thanks a lot for your time and odd time, at least for John and Jeff. Krishna, also, it's too late. Thank you very much for joining and making it so interesting and informal to share all this technology. So just to close, I just quote Jeff. See, challenges are good. Technology changes are good. The challenges make you stronger, and it helps us to share and collaborate to become more stronger. So taking words from Krishna, SODA can help us to become stronger in data management. Thank you so much for joining. Thanks for listening us.
Thanks a lot. Thank you.
Thank you, everybody. Thank you, Soda.
Thank you.
Thank you.
Sunil.
Thank you.
Thank you,
Bye.
Jean-Francois. Thank you, Krishna, John, and Shashidhar. This was indeed a very, very informative panel. Lots of questions flying around. We have some more questions which we'll probably take them offline and we'll get them answered for you.